for today. And today we're covering P8. Where are we? We're covering P8 and P9. So let me find P8 and P9, clean up all that. P7, here we are. P8. In P8, we're going to model. We're going to do some modeling. All right, so this one's kind of a fun one because we do some real world problems here. So let's take a look at some real world problems here. And I've got them written up here. And we'll just see if we can kind of go through these. So let's see here. And I'm going to bring this down so you can attempt to read that. And then I will do some work as well. So what we're going to do is try and solve not just equations, but real world problems. So if we read through this, let me get a piece of paper out here. So given starting median salary, I'll read it if you want, or you guys can read it. Given the starting median salary of a computer scientist, and this is just some example, and it exceeds that of an education major by this amount. And given the starting median salary of an economics major exceeds an education major by that amount, and all combined their median salaries are this amount, determine the median starting salaries of each of these three majors. That's what we're trying to do. So what do we think? Do we have enough? First of all, I think we have to ask ourselves, do we have enough information to solve this problem? And if we do, then let's go ahead and start down the path of seeing if we can solve it. Now, this is more of a, I would say, more of a logic problem than a Math 141, a math type problem. And that's why we do some real work, indicating that, hey, don't be afraid of what we've seen in some of these previous sections. Take a look at this section, and when we go through this, I think you're going to find that you're not going to find these difficult problems. So just kind of put on a new thought process here and say, let's see, how do I solve this problem? If I just read that first sentence, starting median salary, computer science major exceeds that of an education major by that amount. Can I make an equation out of that first sentence?
Yes.
I think so.
All right, go right ahead. One at a time, and let's have some new volunteers. Go ahead. New volunteers, now's your time. And the reason I insist on that is because halfway through the class, when I ask for a student survey and I say what's working and what isn't working, and some students will say, well, you know, I never get to answer because somebody's always talking first and I never get to talk. So now's your time to talk. Patrick, looks like you're on.
Would it be X plus 21?
X plus 21. And what does X represent?
X would represent the education major salary.
All right. So multiple ways to work problems. But if we say X, then we're going to have some table over here that says X is the education major. So rather than having a table, I'm going to change this and just say education salary is ED. So this says education salary plus 21. What is this ED plus 21? What is that supposed to be? What is ED plus 21?
That is going to be the annual salary of a computer science major.
All right. And let's say that CS is for computer science. So can I set up an equation?
Yes, you can set what you've already got written equal to CS.
Very good. That's what I'm looking for. So computer science, starting median annual salary is the education starting median annual salary plus 21, and I'll just put the units here, $21,000. So we have one equation. How many unknowns do we have?
Two.
Two? Let's see. What are the three unknown, or the two unknowns? I'm sorry. What are the two unknowns?
In our equation, it would be computer science and education major.
That's the first sentence. If we keep going, how many in the whole paragraph here, how many unknowns do we have?
Oh, my apologies. 3, I believe.
And what are they?
Computer science, education major, and the economics one.
Okay, very good. That's what I was looking for. So if I say ED for education, CS for computer science, EC for economics, that's what we'll use. So let's read the second sentence and see if we can form an equation out of that second sentence. And when you're ready, open your mic. If we can get a new volunteer, that'd be nice. And give me that second sentence equation. So here's equation one. I'm looking for equation for two.
Ni ven sa Shiu.
So easy.
Go ahead. Second sentence gives me an equation of what? Or does it give me an equation of anything?
The second sentence is
Yeah.
starting median salary of an economics major. So the
All right, now,
EC
Patrick, I'm going to see if somebody else wants to speak before you do it, to make sure that we've got, we got like 35 or more people in here. Let's see. if
Come
we
on,
get
class, step up.
some
Let's-
people. Does
let's
anybody
go.
else
I
want
can
to
try it out. I can try it.
go right ahead?
Is it EC is equal to ED plus 14K?
ED plus 14,000. Let's see. Starting median annual salary of an economics major, and EC is economics, exceeds that of the education major. We said ED for education by 14. That looks good, Alan. Thank you.
Okay.
All right. Who else can give me another equation if there is another equation? We need a new volunteer. Patrick and Alex have helped out. Who else can help out?
I can. Okay, so the third equation will be 140K equals ED plus CS plus EC.
So CS plus ED plus EC is 140. Does everybody agree that those are the three equations?
Yes.
I only got part of that, Patrick. Go ahead. Go ahead.
Yes, I agree.
You're cutting out.
Yes, I agree. Those are the three equations.
Okay. All right. Anybody else agree? We only have one person that agrees.
I
I
agree.
agree with it.
All right. Very good. So the question now becomes, are we able to solve this? We had three unknowns, ED, CS, and EC, and we have three equations, 1, 2, 3. So are we able to solve for those three unknowns? And if the answer is yes, well, then let's go do it. So who wants to step me through the next equation that would allow us to solve?
I'll go ahead and do it.
Good, go right ahead.
All right, so we're going to fill in variables for CS and EC with the values that we've already listed above. So we'll go ahead and start by setting the entire equation equal to the total salary of 140,000.
All right, that'll be on the right. Okay, what do
And
we
that'll
have?
be equal to ED plus 21,000.
So CS changes from CS to ED
Right.
plus 21.
Okay, so we'll go from that angle. Yeah. So then the
Okay.
next you'll replace EC with ED plus 14.
EC is ED D plus 14.
And
Okay.
ED stays constant. So
And ED is here. Okay, good.
When
And
you-
that's now equal to 140.
mhm.
Okay, good.
So when you combine it all together, you should have 140 equals 3 ED
So
plus
now
30.
we have one equation and one unknown.
Right.
We started out with 3 equations and 3 unknowns. By substitution, we now have one equation, but only one unknown. So now, new volunteer, what are we going to do to solve this equation?
Add common factors.
All right, so what are the common factors?
Or not common factors, the common numbers. So you add ED plus ED, then the regular
ED
numbers,
plus ED gives me what?
3ED.
Well, is this just ED?
I think 2ED.
Are there 3 down here? Or are there just 2? What did I miss something here? Let's see. CS is ED
You
plus
wrote in
21.
14 instead of ED. So
Yeah,
right in the
that's
middle
where my
there.
confusion-
Very good. All
You
right.
have
So
3 ED.
So that's ED, and that's ED plus 14. So 1, 2, 3. So we have 3 ED. Okay, and that's 140. And how about any other constants?
21 and 14.
21 and 14.
21 and 14. Okay, so that's what, 35?
Can we move the paper up, please?
Let me move this up a little bit as well so we can, there we go. Let's see, is that still clear? Okay, good. Okay, so is this 35? If we had 21 and 14, that's 335. Okay. All right, are we able to solve this for ED? So 3ED equals 140, and then we need to subtract 35 from each side. Is that right? So if we subtract 35 from 140, we get what? 105?
105.
105.
And then we divide each side by 3, and we get ED equals what?
35.
35.
35, and that's 35 what? Apples?
$35,000.
35K.
35K. All right. 35K. That's 35,000. 35,000 apples?
Dollars.
Dollars. Okay, so we'll put $1 there. So now we have education, $35,000, and that's the annual salary. Okay, so it looks like we have one of them. Okay, are we done?
Not
And
Thank
then
yet.
we have to find the other 2
All right, so
unknown.
all right, so what do we want to find next?
Would we add to find like computer science and economics? Would we just add 35K plus 21 for computer science and then 35 plus 14 for economics?
Okay, computer science, we had that up here. And we said computer science was ED plus 21, and ED is 35, so that's 35 plus 21. So that's what, 56? We've done our arithmetic properly, and that's 56 what?
Apples. I'm just kidding. Dollars.
Dollars, $56.
$1,000.
$56,000, which we'll represent by a K. So I'll say CS equals $56K. All right, good. So now we have ED and CS. Are we done?
No,
What do we need?
We need to find the value for EC.
EC, okay. Do we have an equation for EC somewhere?
Yeah, you have to add 35K to 14K.
So EC equals ED plus 14 from above, and ED we said was 35.
Can you move your paper up, please?
Yeah, and ED is 35. Let me see if I can move that up a bit so we can see more here. There. Okay, plus 14. So that's 49. Is that the value we're going to get there? So now we have EC is $49,000. So now have we answered the question? Or do we
I
still have
believe
work to
so. I
do?
think you have all three values.
And you're going to run into this problem on tests because you're going to run through, and in the heat of the battle of a test, you're going to say, oh, I found an answer. There it is. And you'll say, there's my answer. And you might be tempted to move on. And what I would ask you to do is go back and read the problem and say, let's see, what was it asking me for? Determine the median starting salary of the three majors. Oh, so it wants the starting salary of all three. So that's an answer. And here's an answer. And here's an answer. So I've got all kinds of work going on here. But when I come to grade this with the key, and I say, well, let's see, for ED, it's this. And for CS, it's that. And for EC, it's that. And I found your answers looking here. Okay. So what I'm looking for is when we do these problems and when you do your homework problems, it's really practice for the test, isn't it? So that you know the format I'm looking for and you won't have any problem thinking, gee, did I put that in the format he wanted? Because you've been doing it all along. We've been doing it in our classwork problems and you've been doing it in your homework. Okay. Questions on that? We get through that okay?
Could you do another problem like this?
Yeah, we're gonna do more problems, but let me get through those first. So in this kind of a problem, then we just set up an equation by reading the line. Given the starting median salary of a computer science major, and I said computer science, I said that was CS, exceeds that of a education major. Well, I'll let ED be education, exceeds it by 21. So from that first sentence, I developed that equation. And from the second sentence, economics major is 14,000 more than education. So economics is 14 more than the education. And then I keep reading and it says the combined of the computer science and education and economics is a total of 140. So then I just substituted in here. For computer science, I put in what that substitute was, ED plus 21. ED, I didn't have to substitute anything. And economics was ED plus 14. So I reduced 3 equations and 3 unknowns to 1 equation and 1 unknown using substitution. Then I just solve this by gathering like terms, setting them equal to the constant of 140, subtracted the 35 and divide by 3, and I get the education is $35,000. But then I realized, well, hold it, I can't stop there. I still need the computer science and I need the economics. So just make sure that you've answered the entire question. Okay, sometimes you're tempted to stop right here and say, hey, I figured it out, education's 35. Okay. Problem number 2. Let's take a problem that looks like this. And problem number 2 says solve the equation 85 minus 0.9x equals 25. And it says solve it to 2 decimals. Okay, are we able to solve that kind of a problem to 2 decimals? And if so, go ahead and solve it. And then when you're done, turn on your mic. And I'd like a new person to turn on their mic and step me through it. So I'm not looking for just an answer. I'm looking for the steps that you went through to get your answer. And I'll just say solve for X 2 decimals. And of course, we're going to always round. Anytime we're in decimal notation, we want to round, don't we? Whether it's 2 decimals or 1 decimal or 7 decimals, we always want to round. And I'll just wait for you to finish.
I got an answer.
All right, go right ahead.
So I subtracted 85 from both sides.
Okay, so that leaves negative 0.9x equals 25 minus 85. Okay,
Then I divided both sides. I simplified that to negative 0.9x equals negative 60.
negative 60 by subtracting, or yeah, taking 25 from 80, we got 60. Okay,
And then I divided both sides by negative 0.9.
and you got what?
I got 6.666 is repeated 7, so I made that 6.66, and then I rounded that to 6.67.
Okay, so we rounded that to 6.67.
Yes.
So we've done what they asked. We've rounded to 2 decimals. Does everybody agree with the answer?
I agree.
So we have one agree. Okay.
Yes,
Anybody
I
else?
agree. As
I
well.
agree.
Okay. So what did we divide by?
I got 66.67.
Yes. The question is, what did we divide by? We divided by 0.9. We didn't divide by 9. We divided by 0.9. So x equals 66 point what?
67.
67, correct. Okay. So that's not the correct answer. This is the correct answer. Okay. So we want to make sure that we don't get tricked by not including a decimal point. Read the problem carefully. Okay, questions on what we did there?
Wait, could you explain why it's like 66.67 and not like 6.67? I wasn't
Yes.
exactly like
Yes,
kind of
60,
spaced out there for a second.
60 divided by 0.9. So let me put that in my calculator and see what I get. So if I divide 60 divided by 0.9, I get 66.66, and I round that to 67. Okay.
Oh, my bad. Thank you.
Okay. Other questions on that one? Everybody doing okay?
How come it wasn't by or negative 60 divided by negative 0.9?
It was negative 60 divided by negative 0.9.
Okay, I think I just put something in weird, so I got a weird answer.
Oh, well, do you want me to put it in again?
Yeah, I'm all good now.
Okay, 60 divided by 0.9. They're both negative, so I can either swap sides or multiply through by -1 and make them both positive. Okay, other questions? Okay, if you have questions, be sure to ask.
My question would be,
Yeah, go right ahead.
instead of instead of having both negatives, could you do like subtract 25 from one side and subtract 0.09x from the other, just so that they're positives? You get a different answer. I'm just wondering why that isn't correct.
You do get a different answer?
Do you?
Well, I don't know. You tell me.
Oh, you do not get a different answer. It's the same answer either way.
Okay, great.
You okay, Patrick?
Yeah, thank you.
All right. All right. Any other questions before we go to the next problem? Okay. Now this is a fun one. After a 30% price reduction, you purchase a new computer for $840. The question is, what was the computer's price before the reduction? So go ahead and take some time, and then when you're ready, let's have a new volunteer turn on your camera, not your camera, your microphone, and step me through your process. And on all these, as we go through them, I'm not looking for just your final answer. I'm not looking to say, oh, you know, my answer was 17. What I'm looking for is what steps did you go through to get your answer? And that's what I'm looking for here. How are we going to figure out this answer?
I think I got it. I don't know if I'm right though, but I think I got somewhere.
All right, Alan, go right ahead.
So like after 30 price reduction, it costs $840. So I'm guessing $840 is 70% of the original price.
So what do you want me to write down?
840 is equal to 70%.
840, and then what?
It's equal to 70%.
Equals 70%.
Yeah, and then I'm guessing I can shrink it down 70 to 10% to get after that I can like times up to 100. So I'll divide it by 7 both sides.
Divide each side by 7,
Yeah,
like that. Okay.
yes, that should equal 120 equals 10%.
So what do you want me to write next?
120 is equal to 10%.
120 equals 10%.
And then from there, you can figure out what 100% is by just timesing it by 10 as well. So 120 times 10, that should give you your final answer.
120 times 10,
Yeah,
and that's 1200.
yeah. Since you do 70 for 10% too, and 10% times 10 equals 100%.
So 120 times 10.
Yeah, correct.
Okay. So your final answer is 1200,
$1,200, yeah.
and that's dollars. Okay. And that's going to be the price before. So we're going to say
Correct.
here's my answer here. Anybody do it any differently?
What I did was I multiplied 840 by 0.3 because
840 times 0.3. Okay.
Okay, I hope I'm getting it right. And then I got 252.
Let me just do that. Multiply 840 times 0.3, and you got 252. Okay.
And then I added 840 again.
840.
I added 840 to 252.
Oh, add 840. Okay. Add 840. And we
Like
get
that.
1092.
Mhm.
Okay.
Yeah, I'm not sure if I did it correctly.
All right. So we have an answer here. I'm going to put a question mark because we have different answers here. So, all right. So we have those two answers. Did anybody else do anything different?
I agree with the second one.
This one?
Correct.
All right.
I
So we
did
have
it in like a similar way to Alan. I did 840 equals 0.7x.
840 equals 0.7x. Okay.
And then I divided both sides by 0.7.
0.7, 0.7. So x
And,
equals
X equals $1,200.
1,200. So really you're saying I got the same answer as this one. So we have
Yeah.
a couple people got 1,200 and a couple of people got 1092. So we need a tiebreaker here. We need somebody else to weigh in here, or a couple more
Yeah.
people to weigh in.
I did it the same way that Leal did, and that's using a variable. So Alan did everything right, but he just didn't use a variable, which is kind of part of what we're doing in math here. So
All right. So what answer did you come up with?
1,200. 1,200 is right.
1,200. So you got this answer. Okay.
I
Anybody
got
else?
the 1092.
You got the 1092. Okay.
I also got 1092.
1092. Okay.
I don't think that way is correct because it would be 30% of the 70%. It's not the 30% that you're missing from the full price because 840 isn't the full price.
But 840 is what you paid after you got a 30% discount. So you have to add 30% on top of the 840 to get your original value.
Yeah,
right? So
but
30%,
but
listen,
30%,
30% of your original value on top of the 840 gives you the original value. 840 is 70% of your original value. That's
no,
why
I
Alan's method is
know.
correct. So it's
No,
12.
I know. I'm saying the other method isn't correct because when they're just trying to figure out 30% of 840, it's not the same as getting 30% from the original price. So you can't just add it
I see.
on to 840.
I apologize, Leo. I didn't understand what you were saying. I should have let you finish.
Yeah, no, that's fine.
That's a great point. Thank you for showing that. That's eye-opening.
So do we have a correct answer here or not?
If
We
you could
have-
show us the correct answer, that would be really helpful, Professor.
Well,
Thank
I
you.
will go through it, but I would just want to make sure that everybody's had a chance to kind of look at it, give it a try.
I also got 1200 using the
Also got-
bottom method.
Also got 1200, so we're 3-3. Because we learn math by doing math. We don't learn math by watching me do math. So I will go through it, and but we have, looks like we're kind of evenly divided here. So let me solve it how I would solve it, and you see whether you agree or disagree. So if I can get a clean piece of paper here. So I said the original purchase price. Well, what is the original purchase price? We don't know it, do we? I can call it P. Can I call it P for the original purchase price?
Absolutely.
All right. And I got a 30% reduction from what? The purchase price? So I got a 30% reduction. Okay. After a 30% reduction. So here's my 30% reduction from the original price. And when I took that 30% from the original price, I got 840. Now, before we go any further, we have to agree with what we're starting with, because we can, if we have a wrong equation, we can go down lots of different paths. So do we agree this would be an equation that we would use? After a
Yes.
30% reduction from the original price. We don't know what the original price was, but we know we've got a 30% off. Okay. So now I could say, well, that's, if this is correct, that's all I have to do is solve that equation. Now, for those of you who are saying, gee, I don't know whether I should be taking this course, it looks like it's too hard. Does this look like it's too hard? We've done this in 97 and 98, 99, haven't we? We could factor out a P here and say P times what? 1 minus 30%.
30.
30% equals 840. Okay. But when we're dealing with percentages, we don't subtract 30% from 1, do we? We change that 30% to a what?
0.3.
0.3 equals 840. Okay. So 1 minus 0.3 is what?
0.7.
0.7 equals 840. Divide each side by 0.7 and we get P equals, and let's see, if I take 840 and divide it by 0.7, I get 1200. And that's dollars. So this says that using this equation and then solving, I get $1,200. So if we agree that this equation is correct, then we solve it and we get down to 1,200. Okay, so let me go back to the original. After a 30% reduction, here's the 30% reduction. From what? From the price, from the original price. So 30% from the original price, that's 840. So what was the original price? Well, it's P. So then I just go through and solve and I get 1,200. Okay, so for those of you who got 1092, do you agree with what's going on here? And do you see what the difference is?
Yeah, that makes sense.
Okay,
Thank you.
yes. All right, let's try another one. It says the length of a regular, no, not regular, a rectangular basketball court measures 44 feet more than the width. So let's see, here's our basketball court. The length, so here's the length, here's the width, and the length is 44 feet more than the width. And then it talks about the perimeter is 288. Okay, so how would I describe the length given what the problem states?
Is it 44 plus width?
So you want this to be W plus 44. Now, does that make
Yes.
sense? The length of a rectangular basketball court measures 44 feet more than the width. So that looks right. 44 plus means more than the width. And here's the width. Okay. If the perimeter, well, let me stop. Does everybody agree with that first sentence that makes it look like this? Anybody?
Yes.
Anybody have a problem
Agree.
with that? Okay. Second sentence, if the perimeter is 288. So what makes up the perimeter if we're looking in terms of length and width? What would we say the perimeter is?
Is
So
2L plus
being
2W.
2 lengths plus 2 widths. So it's this length and this length and this width and this width. So if we add this plus this plus this plus this, we should get it. Make sense? So 288 equals 2 and length. Well, we can put length, but here we have length in terms of width. So we could say 2W plus 44, couldn't we? Plus 2W. Does that work? Any errors so far? So 288 equals, take this 2 and distribute it. And I'll get 2 times W is 2W plus 2 times 44 plus 2W. Everybody agree so far?
yes.
Combine those 2 W's and I'll get 4 W's. And subtract 88 from each side and I'll get 200. So solving for W, I get W equals what?
50.
50. And that means the length is what? 50 plus
44,
44, which is
94.
94. So it looks like if our logic is good here, that we end up with a width of 50 and a length of 50 plus 44 or 94. Okay, everybody agree? Anybody disagree?
Wait, could you repeat the let's say that part of it? 'Cause I kind of got lost in the middle of it. Could you
Well,
repeat it?
yep, I certainly will. So let's length, width, and the length based on the question. Let's see, here it is right here. Let me get this down so you can see it here. So based on this question, what's the length in terms of the width?
Width plus 44.
And then it gave us a perimeter of 288. And we said the perimeter was equal to what? 2 lengths? Length, plus 2 widths, width. Okay, now what do we have to do? New volunteer. We don't want to have just one person talking. We want everybody to have some fun. And I can call on people randomly if that's what you'd prefer me to do.
So we have length equal to W plus 44.
All right, so 288 equals 2 times length, which is W plus 44 plus 2W. Okay. Are we done?
No, then you distribute the 2 into the W and the 44.
288 equals 2W plus
88.
88.
88 plus 2W. Okay, good.
Combine
Then we add
terms.
Combine these two. And I get 4W. What do I do with this
Yes.
88? What do I do with this?
so we subtract.
Subtract from each side.
Yes.
Subtract negative 88, subtract negative 88. And on the left-hand side, I'm left with what?
200.
Very good. Now, the person that didn't get what we were doing, can we solve for W?
Just divide like 200 by 4 in order to get W.
Okay, Alan will divide each side by 4, and we'll get W equals what?
Oh, length processes.
50.
50.
50. Okay, so Alan says W equals 50. Alan, what's the length?
50 plus 4, 94.
50 plus 4, 94. Okay, does that make sense?
Yeah, it makes more sense now. Thank you.
Okay, sure. Yeah, be sure you ask questions if something doesn't make sense. Now's the time to ask. Okay, let's try another one. Let's see, problem 5. Let's see, do I have any more paper here? Do I need more paper? Yes, I need more paper. Need more cowbell, as they say in show business. Let's see, where is my paper? Here's some paper down here. Okay, problem 5. A rectangular garden measures 16 by 12. Oops, you can't see that. There we go. A rectangular garden measures 16 feet by 12 feet. So let me just draw that. 16, 12. A path of uniform width is to be added so as to surround the entire garden in its uniform width. So I'll just draw a path around here and I'll call that uniform width. And I'm going to extend that out so I can see where the path is here. So here's the garden. And outside the garden is the path of uniform width. These widths are all the same. The landscape artist doing the work wants the garden and the path to cover 320 square feet. That's an area, isn't it? So the area of what? The garden and the path. So I'll say G and P, area of G and P is 320 square feet. And so the question is, well, how wide should this path be in order to get 320 feet? So we look at that and say, well, I need to get an equation in here somewhere to solve this thing. Anybody have any ideas what we could do to set up an equation?
Are we going to use the area formula?
We can use whatever you'd like to use. In other words, there may be more than one way to solve a problem. I'm just looking for some help to solve this problem that we can all kind of learn from. Anybody want to help me out?
More than those dimensions.
We can do whatever you'd like.
So length of 17, width of 13.
So you want to go out here, make this 17 like that.
Sure.
And you
So you
wanna-
know, Patrick, that's only adding 6 inches to either side. So
Well, we'll put down whatever you want. You want 17 or what do you want?
What do you think, Chris?
I mean, I would just, if you want to add a foot to either side, that's a reasonable width for what you're doing. I would actually add 2 to either side, but 17 works. It's fine. I mean, I'm not an expert.
I'll go with
Overall width here of 14. All right, that's fine. And now what do we want to do? So you said, let's make this one and this one and this one and this one. So we're 18 and like that. And this is one and that's one and that's one and that's one. So it's 12, 13, 14. All right, next. This is how we learn.
I think we'll have to check in the calculator by multiplying the dimensions 18 and 14 to see if we get 320.
Okay, 18 times 14. When we do that, what do we get? 18 times 14, and I get 252 if I did my multiply properly.
I have another way to do it.
Okay,
So let's if wide of the bath is x, so 12 plus x times 16 plus x should be 320.
so where do you want me to, did you say H or X? What did you
the
say?
wide of the bath is x.
This, oh, the width of the path.
Yeah. Yes.
Oh, right. So you don't want this to be 1. You want this to be X, some unknown value. Is that what you want?
Yes.
Am I
So
writing this correctly
X.
then? So you want it to look like this?
Yeah. And then 12 plus x times 16 plus
12
x.
plus X,
No. Yeah.
16 plus X, like that,
Yes. Equal 320.
equal 320. Okay.
Yeah.
All right, good. So
And
12 plus X and 16 plus X. Okay, good.
Yep.
And now what?
we distribute them. We got 12 times 16 is 192.
192
Yes. Plus 12x.
plus
12x
12X
plus 16x plus x x squared
equals
is
320.
320. Yes.
Okay.
And then we have 320 minus 192 is.
So we're taking this, putting it on the other side.
Yes.
By
Should
subtracting from
be
each side.
128.
128
Yes. And we have 12 plus 16. We have 28x plus x squared.
plus X squared. So X squared plus 28X equals 128. Is that what you want?
Yes.
Okay.
Yes.
Right.
And then we have x is the common one. I mean x and then times 28 plus x.
So what are we doing next? What did you want me to do?
I want you to take the x out.
Oh, factor
From-
out an X.
Yes.
X times factor out an X out of here. That's X
Plus
plus
28
28 equals 1.
equal 128.
All right. Very good. All right.
So x should be either 128 or x plus 28 should be 128.
You want it like that?
Yes.
Okay.
Wait. Yes.
Okay. So here we have X is 128 and X plus 28 is 128, or X equals
100.
28. So you want this to be
Wait.
100. So
Isn't
X, So X is the path width again. That's this width up here. So you want the path width to be either 128 or 100. Is that what you're thinking?
No.
No, that's not what you're thinking.
Can I see the problem again?
Yes, the problem, let's see, where is it? Right here. A rectangular garden measures 16 feet. Let's see, I need to slide this down here like this and like this. A rectangular garden measures 16 by 12. 16 by 12. A path of uniform width, here it is added around the outside. The landscape artist doing the work wants the garden and the path to cover an area of 320. Garden and the path, so that's this area out here, isn't it? Is going to be 320. How wide should the path be? And one person said, let's make it a foot. Another person said, let's make it 2 feet. Another person said, let's make it X.
I think I messed up somewhere. Can you help me?
Sure. Anybody want to help out?
Could I give it a try?
Yes, let me get another piece of
So
paper here.
can we just go through the problem that she was originally doing, but like
Yep.
at the end, I did it a little bit different.
Just go ahead and give me your method. What would you like to do?
It's the exact same one that she was doing. It's just at the end, I factored it different. So can I see what we were doing earlier? So where she did x squared plus 28x equals 128, I would just subtract 128 to the other side and make it x squared plus 128x minus 128 on one side of the equation.
So X squared plus 28X on this side.
Yeah, minus 128.
Minus 128.
Yeah, and then I would go and factor that.
So you brought that over then. So you moved that
So then I
over.
would go and factor that, and I know that -4 times 32 equals 128, and
So
32 minus
we're not doing this down here anymore.
no.
Okay. So what are we going to put down here?
So I just like checked on the calculator if any factors went into 128, and I found -4 and 32. And that would
-4
also
and 32. Okay.
and 32 minus 4 would equals 28. So then I would factor that as x minus 4 and x plus 32.
X minus 4 and X plus 32.
Plus 32, yeah.
All right,
Then
now
I'm going to set both of
let's
those.
just FOIL that, make sure. So X times X is X squared. Last is -128. And then outer is 32, enters that. So that looks good. All right, keep going.
So then I would set both of those equal to 0. So x minus 4 equals 0 and x plus 32 equals 0.
X plus 32 equals 0. Okay.
And then on one side it's x equals 4 and the other side is x equals -32. Then it's just a process of elimination in which answer is, because there's no way that you're going to have a negative perimeter. So then it would be the positive answer.
All right, so X equals 4.
So then you would just add 4 to either 12 or 16 to get the.
All right, so let's test your answer then. So we had 12 plus this X is 4 and this X is 4. So this becomes 16 over here. 16 is the width. 12 plus 4 plus 4 times. And the length was 16, and we had 4 and 4, so 16 and 4 is 20, it's 24. So now we have an outside of 16 and 24. So if I multiply those, 16 times 24, and I get 384.
Wait, isn't it 16 and 12? So wouldn't it be 16 and 20?
Correct.
So then it would equal 320.
Well, 16 is here. Plus
and then
4.
the other one's 12. So then it would be 20 and 16.
Well, 16 times 12 is the inner area here.
Right. So if I'm adding 4 to each of them, right? So then it would be 20 times 16.
16 times 12. So the inner area is 192.
Right.
And you said this X is 4, right?
Right, so if I'm adding X to 16 and to 12, that would give it 20
You're
and
not-
16,
You're
right?
you're not adding 4, you're adding 16 plus X plus X. Like we have a path on each side. So that's 16 plus 4 is 20 plus 4 is 24.
So if you go into the equation where it's 12,
Oh, so then it would be 2 for X.
So then it would be 2 for X. So you want to substitute a 2?
X,
So 12 and 16 should plus 8 each.
12 plus 8, so that's 12 plus 4 plus 4, that's 20.
Yeah.
And then
And then-
16 plus 4 plus 4, that's 16, that's 24.
Yes.
So 20
That's what I
times 20, so 20 times 24, let's see, 20 times 24, that gives me 480.
the outside perimeter should be 20 length and 16 width to equal 320. Is that correct?
Now, again, I'm looking for a method to how to solve this thing. Right, the outside dimensions, let's see, if the outside dimension is 320, outside area, yeah, again, it's looking for the path width. It's looking for this X value.
So in the equation underneath that where it says 12 plus X times 16 plus X equals
Yes.
320, we solved for that X right there.
Yes,
and
we did.
we found that that equals 4. So if we plug a 4 back in, so it's 12 plus 4 and 16 plus 4.
Well, there's an X here, that's 4. And there's an X here, that's another 4. So it's 12 plus 4 plus 4, not just 12 plus 4.
So, Professor,
would it fix the problem if we just add, like if we change the 12 plus X and the 16 plus X to 12 plus 2X and 16 plus 2X?
Yeah, I agree.
What do we think, class?
Yeah, that works.
Yeah, that
So,
works.
so we have a width here plus an X plus an X. So that's 12 plus 2X. And here we have an X and an X. So that's 16 plus 2X equals 320. Does that work better? Let's try that, see what we get. So if I get 12 plus 2X times 16 plus 2X, and that equals 320. And now we want to solve that for X. Okay, are we able to do that? And how would we do that?
we can go about the same process as earlier.
Okay, so
So-
we'll FOIL it.
Boil it out. We should get 4x squared.
That's if we do this times this, we get 4x squared, okay,
Plus 24x.
plus 24x, that's 12 times 2, okay.
Plus 32x.
Plus inner is 32x.
And we
okay.
still have 192 at the end.
12 times 16 is 192, and that's all equal to 320.
Yep.
Okay, good. All right, and then what do we do?
Subtract the 192 from each side.
Is it a
No.
question? Is it a question or a statement or
Disregard that last statement, sorry.
just disregard? Okay.
Well, combine your term for your like terms first so that we
Okay.
get 56. Yeah.
All right, 4x squared. Then we only have that x squared. Then we have some x's. So how many x's do we have?
We have 56.
56 of the x's. And then we have a constant here. What's the constant going to be?
192.
192.
192 equals 320. And remember, we want to, the idea here is we want to solve this thing for x.
So then if you do what Megan said earlier about factoring it out,
All right, what are we factoring here?
you can factor that in the entire left-hand side of the equation. Oh,
Alright.
excuse me. You got to, or sorry, do the step that Patrick said, subtract the 192. or pardon me, I'm mixing it up. Subtract 320 to get 4x squared plus 56x
4x
minus
squared
120.
plus 56x, and then subtract 320 from each side.
Yeah,
And when I subtract 192 from 320, what do I get?
128. And then we
128.
pick up where Megan was
So is it positive or negative 128?
negative
Negative 128, and that's equal to
0.
0. Okay. All right.
And then repeating what Megan did earlier, you can factor it out into 2x minus 4 and 2x plus 32.
2x minus 4 and 2x minus 32
Plus 32.
plus 32. Okay, so if we do this first, so we'll FOIL it to verify. 2x times 2x, 4x squared, 4 times 32, that, and then 64 minus 8. Okay, that looks good. All right.
So then,
Great time.
Megan, do you
time.
want to pick back up since you were the one who did this originally? Or
We'll take our break and we'll see you at, let's see, I have 4:02. I'll see you. How about 4:10? Can we make it 4:10?
Yes.
All right, we'll see you guys at 4:10.
Recording stopped.
Okay, my computer shows 410. Are we all back?
Yes, and I
Yeah.
also have the answer.
Oh,
I
good.
know where I mess up.
Good. What did you get for an answer?
It's 16 and 20 because instead of calling x for just the wide of one side of the path, I should have called x for
Recording in
the wide.
progress.
I should have called x for the wide of both sides of the path.
Yes.
Yes.
Yes, that's correct. Okay, very good.
Thank
And
you.
then when we reduce that, we end up with a path width of what?
I'm sorry.
When we go through that, what do we end up with the final answer for the width of the path?
It should be 4.
The width of the path?
Yes.
2.
2.
X-
2 on
X
each side.
equals 2.
Oh,
X
yeah,
equals 2.
2.
Yeah,
Thank
width
you.
of the path is 2. All right. Let's take the next problem. A radio tower. Here's my radio tower right there. And it's supported, and now here's the ground. So here's the ground, and I'm going to say that's 90 degrees. And I'm going to say the radio tower is supported by 2 wires that are each 130 yards long and attached to the ground 50 yards from the base of the tower. So what that's saying is I have a cable that goes from here and it runs down to the ground here, and it's supporting this tower. So it looks like that. And it's saying 2 wires, they're 130 yards long. So this wire was 130 yards and attached to the ground down here 50 yards from the base of the tower. And here's the base of the tower. So this is 50 yards. And this is distance of 130. And then it comes back and wants to know, how tall is the tower? Is there a way to figure that out, or do we have enough information? Because it did say there were 2 wires each attached. So I don't know if that makes a difference or not, but I just show the wire here.
We could use a squared plus b squared equals c squared to solve this.
Equals c squared. Okay, and how would we use that to solve this?
So a could be the 50. So
A
yeah,
is-
50 squared. Yeah.
So A is 50, and where's B?
B is unknown, but
And where is it on the diagram?
the oh my god, with the height of the tower. Sorry, I forgot
here?
the word for a second.
This B, okay, and what is C?
And C is the length of the wire.
All right, very good. So A squared plus B squared is C squared, and what are we solving for?
We're solving for C. No, for B. Sorry.
Solving for B. So B equals what? I mean, I'm looking for the equation.
Oh, C squared minus A squared.
C squared minus A squared. That's what
Yeah.
B equals?
Yeah. Oh, that's, you would have to root the C squared minus A squared.
So we want to take the square root of this.
Yeah.
So B equals the square root of C squared minus A squared.
Yeah.
Everybody agree? Anybody disagree?
I agree.
Okay. All right. So if we substitute values in here, what do we get? C squared would be what? 130 squared minus A squared is 50 squared. So we want the square root. Let's see if we can do that in one fell swoop here. The square root of 130 squared minus 50 squared. And if my calculator works, let's see what I get. 120. Is that squared? 120 squared? What is that 120? Anybody? I put that stuff in my calculator. It gave me a 120, and the question is, what is that 120?
It's
We have
the
to
height of the tower.
in what? Feet?
Oh, yards.
Yards, because we
Oh,
were given
yeah.
the value in yards, weren't we? So B, the height of the tower, is 120 yards. Okay. Make sense to everybody? Questions?
So to get a single B, you just square rooted the B squared and did the same with the other side. Is that
Well, let's use this equation here. B squared equals C squared minus A squared. Is that the way you'd like to look at it?
Yes.
Sometimes what I do is I start skipping steps. So if I skip a step and you want me to go back, just tell me. So we said B squared equals C squared minus A squared. But we're not solving for B squared, we're solving for B. So how do I solve for B?
So you take the square root of both sides then?
Is that a question or a statement?
I'm uncertain, so that's my uncertainty.
So that's a question.
Sure.
So the answer to the question is yes, we take the square root of the left side and the square root of the right side. So the square root of B squared is what?
B.
B equals the square root of C squared minus A squared.
Thank you.
Which is, yes, sure. That's what we had here. And then we just plugged in numbers. So if I skip steps and you guys want me to go back, just let me know. All right. Very good. Let's see. Is there another half I can write on? No, I guess not. So let's get rid of that and get a new piece of paper here. And I'm going to stop on P.8 at this point and go to P.9 to make sure we get to cover everything we're supposed to cover. So P8. Let's go to P9. What does P9 ask us to do? Let's see here. P9 says we're looking at linear inequalities and absolute value inequalities. So we're going to find out what that means. And so the objectives of this section is to use interval notation. We're going to find out what that means and use it. We're going to find intersections and unions of intervals. And we're going to solve linear inequalities, solve compound inequalities, and solve absolute value inequalities. Okay, so that's the plan. Let's take a look at some example problems that step us through those kinds of applications. So to start out, if I give you an interval that looks like -2 and 5, like that, and I say
Can you move the
that's,
paper down a little, please?
yes, sorry, and that's interval notation right there. And I say, let me just move this whole thing back here a little bit. There we go. So this is interval, interval, interval notation. And I say, can I see that in real line number notation or just graphical notation? I want to graph that. Well, what am I going to graph it on? Well, I'm going to graph it on the real number line. There's the real number line. And on the real number line, I can pick out some point and say, that's 0. And it extends all the way to the right forever and extends all the way to the left forever. So here's my real number line. And I want to plot this on the real number line. So it goes from -2, -1, -2, to +5, 1, 2, 3, 4, 5. And this symbol says what? That symbol says I include the -2. So if I put a symbol that looks like that, that says I'm going from -2, including -2, and I'm going up to 5, but this parenthesis says I'm going as close as you want to get to 5, but I never include 5. So I'm going to put that like this. And I'm going to color that just so that you might be able to see it a little better. So when I say the interval from -2 to 5, and I put that on the real number line, it would look like this and this. So that's two notations. Here's one notation. Here's graphical notation. There's a third notation that's used, and it's called set notation. And set notation is between two braces. That includes the set. And when I put up this kind of a set notation, I'm saying X is such that it is greater than or equal to -2, but it's less than 5. So I use this less than equal to sign and this less than sign here. So keep in mind, we have the signs of less than, or equal, greater than or equal, and greater than. Okay, so those are the various signs that I can use when I'm talking about linear inequalities. Here's an equal, greater than or equal, less than or equal, greater than, less than. So I'm looking at values that X can take on from -2, including -2, up to 5, but not including 5. Okay, and this would be the set notation. So three notations: interval notation, graphical notation, set notation. I'm going to stop at that point and make sure that we're all understanding it. Again, I don't think this should be new. I think you've covered it 97, 98, 99 in those math classes, but I'll stop at this point and verify. Questions on that at all?
Yes, Professor, we put X such -2 less or equal. I feel it's greater or equal.
Yes, X is greater than or equal to -2. That's what this is. So X
Oh,
is on the
X,
right-hand
okay.
side.
Okay, I see. Thank you.
Yeah, so if we look here, X is greater than or equal to -2. And if we look over here, X is less than 5. Okay, other questions?
For graphical notation, I've always used like an empty circle or a solid circle to include or exclude. You would prefer us to use these brackets?
No, you could use either one.
Okay.
If you'd prefer to use a solid and an open, that's fine. That's legitimate.
Great.
Either one works. Okay, other questions?
So are solid dots for like if it includes the number?
Yes, this solid dot corresponds to this left bracket here.
And the
And
empty
the
ones?
open circle corresponds to this right paren.
Thank you.
Okay, other
Wait,
questions?
so like on the test, you want to like write down 3 different versions, right? Is that basically what this unit is about?
If the question says, show this in 3 different methods, yes. You just want to read the question and make sure that you're answering the question. If it says, I'm giving you this interval, show me what it looks like graphically, you would say, well, it goes from -2 to +5, and it includes the -2 and doesn't include the 5, and it's this blue line here.
Could you explain a bit more on the set notation? Because I feel like that part, I'm not really keen on that.
Yeah, set notation is between these braces. And set notation says we start off with these braces. And we say the variable is X. And we have all X's such that X is greater than or equal to -2. And X is less than 5.
Okay.
That puts it in here.
Could you do another example if you have a chance?
Yes.
Okay, thank you.
Let's say we have 2 intervals that are given. I have one interval, it's 1 and 3, and looks like that. And I want to AND that. And that AND symbol is that upside down U. I want to AND that with a 2 and a 6 interval. So if I want to do that, I can say, well, let's put that on real number line and see what it looks like. So here's my real number line. Here's a 0. Here's my positive infinity and negative infinity. And I want to put this first interval on this line. And I'm going to say, well, I'm between 1 and 3. 1, 2, 3, 4, 5, 6, because this goes out to 6. So there's 1, 2, 3, 4, 5, 6. And the first interval goes from 1 and includes 1. So I'm going to put a left bracket here. And it goes to 3 and includes 3. So I'm going to put a right bracket here. And I go from 2, but not including 2. So that would be a left paren, to 6, but not including 6. So that would be a right paren. So now on my real number line, I have left paren, excuse me, left bracket, left paren, right bracket, right paren. And what am I asked for? Well, let's go back and see. Well, I'm asked for an and. I want to and these values. That says I have to include both. Well, the only place that I'm including both is right here, isn't it? Here and here. That's the only place I'm including both, from the left to the right. So I'm including that, and I'm including that, and where they're including both is right here. So I could say open circle, close circle from 2 to 3. I could say in interval form, I could say, well, it goes from 2 and includes 3, like that. So in interval form, it would look like that. In graphical form, it would look like that. What would it look like in set notation form? Well, let's see. Set notation is between these braces. And we say, well, our x goes from where? Well, it's greater than 2 and does not include the 2. That's what this indicates. And it's less than or equal to 3. That's what this indicates. So in set builder notation, if we want to build a set, it would look like this. If we want to graph it, it looks like this. And if I want to have an interval form, it looks like that. And I could also graph it with the open circle and a closed circle if I want to use those terms as well. Okay, questions?
So if I'm expressing this in graph form, will I have to like circle the union area or?
And yeah, if I put this in graphical form, I'd have my line here, I'd have my 0 here, 1, 2, 3, and you'd say it goes from open circle all the way to closed circle at 3. So it goes from 2 to 3. Looks like that.
Would we circle 2 and 3 to indicate that that's the union, or would you be able to figure that out?
No, that's what this is. Here's the open circle from 2, and it goes to the closed circle at 3. That's the same as this.
Okay, so
this, and this are all the same, and these are 1, 2, 3, 4 ways of saying the same thing.
Okay.
Okay. All right, let's try a problem. Let's say I have 2 minus 3x is less than or equal to 5. And what am I going to do? Well, I'm asking you to solve. And let's put it in all notations. So let's just show all, just to see if we can do it. So let's solve this thing for x. Well, I'm solving for positive x, not negative x. So I'm going to first of all add 3x to each side, which will get the x over here. So now I have 2 less than or equal to 5 plus 3x. I'm solving for this thing here. So I'm going to subtract 5 from each side and get 2 and a negative 5. That's going to give me a negative 3, isn't it? That goes away. And that's 3x. So if my addition, if my arithmetic is correct, then we're here. And then I divide each side by 3 because I'm solving for just x. So this says x is greater than or equal to what?
-1.
-1. So there's my solution. And I want to show it in 3 formats. 1, 2, 3. Interval, graph, and set builder. So in interval notation, what would this solution look like? X is greater than or equal to -1, and I want to show it in interval notation. Let me pull this down here to make sure you can see what's above here. Let me just raise that up a bit. Focus that.
Would you do a bracket -1, comma, infinity?
Bracket -1. Okay, so that says
To positive infinity?
and then you want to put a comma here.
Correct.
Yes.
Okay, comma and positive infinity. And then a what, a bracket or a what? It's going to be a paren, isn't it? In interval notation, we're going to say -1, including the -1, because that's what this bracket means. Out to infinity, but not including infinity, because there is no number that's infinity, is there? No matter what our number is, infinity is always going to be larger. All right, so in interval notation, we would look like this, wouldn't we? Everybody agree? Questions?
So we won't have to show any work in this, right?
Well, we've done our work right here.
Yeah, okay.
And
Can you
then we,
explain that part again? The part where you circle? That part kind of like messed me up.
okay.
How'd you manage to get down there?
All right, so I had 2 minus 3x less than 5. I wanted to solve for positive 3x, so I subtracted 3x, excuse me, I added 3x to each side. So that cancels it here and gives me a 3x on the right-hand side. So far, so good?
Yeah, so far so good.
And then we have this 5. I want to get to the other side, and I get it to the other side by subtracting it from each side. So if I subtract it from here, that gives me 0, and subtract it from here, I get -3. So on the left side, I have -3 less than or equal to 3x. And I'm solving for x, not 3x, so I divide through by 3. And I get x greater than or equal to -3 over 3, which is -1.
Oh, okay.
So
I get now.
here's my solution, and then I put it in interval format, look like this. Graphical format, well, let's see, I'll draw my line. I'll put a 0 here. And then what's graphical format going to look like? New volunteer. Let's get somebody new, have some fun.
It will be, you place the bracket at the -1.
-1, so we'll have a bracket here like that, or does the bracket go this way?
No, the first one is correct.
Okay, we'll go like this, okay. And then what?
Do you draw a line to the right side and then I think to have it like so that it's infinite, you add an arrow. Yeah.
Okay, and I can put plus infinity out here. So I could say, well, it sort of looks like this. So it looks like that, doesn't it? How about set builder notation? Can we put it in this notation, or does that not work? Set builder would be like that. So X such that what?
-1. Go ahead, Patrick.
-1 is less than or equal to X. And then I'm not sure on this, but I put X is greater than or less than infinity.
Positive or negative?
Positive infinity.
Okay. So in set builder, we have X such that -1 is less than or equal to X, and X is less than positive infinity. Okay. Everybody agree with that? Anybody, any questions or anything what we did there?
Looks right to me.
Okay. All right, good. So we solved it and we showed it in all the forms. Okay, very good. Let's see, looks like I can work on the back here. How about we do one with has a fraction? Because those are always a little more fun to work with. Let's say if I had an X minus 4 over, let's say 2, and I say that's greater than or equal to X minus 2 over 3, let's say, and that's pretty straightforward. So let's just say plus 5 over 6, for instance. And what are we going to do? Well, we want to solve. And graph, well, let's just say show all. So we want to be able to solve this thing first, and then we want to show all the possibilities. We want to show interval. And we want to show graph. And we want to show in set form. Okay, and the interval form up here. Okay, so let's go ahead and solve for this thing, and then we'll fill these guys in. So we've got a term, and a term. And if we're going to combine these, what do we have to do in order to combine those? What's the general thing we have to do?
Common denominator.
Common denominator. Okay, can we find a common denominator? What do we think it might be?
It could be 6.
6, okay. So if the common denominator is 6, what do I have to do to this first term here?
Multiply it by 3.
Multiply it by 3, okay, like that.
Yes.
Okay.
No, it needs to be 3 over 3.
3 over 3, okay. Whatever I do to the numerator, I have to do to the denominator, okay. Greater than or equal to, and I have an X minus 2 over 3. So if I'm going to make a common denominator here, what am I going to do?
Multiply by 2 over 2.
2 over 2, okay. And how about over here, the last term?
I'll just keep it like that.
All right, good, good. All right, so are we now able to get rid of those denominators since they're all the same? This one's 6, this one's 6, and this one's 6. Is there a way we can just get rid of those things and simplify this thing?
Yes.
What are we going to do?
Multiply through the top. Multiply your numerators and combine all the terms.
So we're going to multiply the numerators by what?
So 3 times X minus 4 is.
No, what are we multiplying the numerators by?
You're multiplying through the fractions that you just.
So we're just leaving this 3 and 2 here and multiplying through here. So we get 3x minus,
over
3x minus 4 over 6, like that.
Well, 3x minus 12, but yeah.
3x minus 12, okay. 3x minus 12 over 6.
Yes.
Greater than 2x minus 4 over 6, like that.
Yeah.
Plus 5 over 6, like that, okay. So I guess we can't get rid of this denominator, then we'll just leave it there. Okay, now what are we going to do?
And you can add 4 and 5 on the left. Yeah, the right side. So it would be
We're going to combine these two. So we have 2x minus 4 plus 5 over 6. Is that what you want?
Or you can just say 1 plus 1 over 6.
All right, so that becomes 2x plus 1 over 6 because we combine those. Okay, fine. What about the left side? What are we going to do there?
So go ahead and we'll keep 3x minus 12 over 6, but then we're going to multiply both sides by 6 over 1 to get rid of the denominator.
Okay, we could have done that way up here, couldn't we?
Is it better to do it up there, Professor, or?
Well, we've had to carry it all the way down. So I would say, yes, it would be simpler because once we decide that the common denominator is 6, we can just get rid of it and say, well, we can just
Okay.
get rid of those by multiplying through. We don't have to carry it down. So if we multiply through by 6, we're just canceling those, aren't we?
Yes.
Okay. So we're ending up with 3x, if my arithmetic is correct, 3x minus 12 greater than or equal to 2x plus 1. Okay. Everybody okay so far? Now, can we simplify? So we have a 3x here. We want to gather our terms. We have a 2x here. Can we combine those? And how do we combine them?
Subtract 2x on both sides.
Okay, so that leaves x on the left side. Those cancel. X minus 12 greater than or equal to 1. Okay.
And you add 12 on both sides, and it'll be x is greater than or equal to 13.
X greater than equal 13. Okay, so here's our solution. Are we done? Because that's what's going to happen on a test. You're going to rush through this thing and you're going to say, wow, I did all this work. X is greater than 13. Great. What's the next problem? But what were we
No, you
asked to
gotta
do?
show it.
Yes, we were
You gotta
asked to
put
do
it-
these three things. Good, good. So let's go ahead and do that. So an interval notation, what is it going to look like? Anybody? New volunteer?
Parenthesis, I'm gonna guess positive or wait, would it be negative infinity? I'm not sure which infinity it would be, but that comma 13.
Infinity here, comma 13 like that.
I believe so, yeah.
And then what do we want on the right-hand side?
Bracket.
A bracket like this. Okay. Anybody else? Let's see, this is infinity here. Okay. All right, now I'm going to put a question in. because we don't have any agreement yet.
It's actually the other way.
It's other way.
All right, tell me what to write.
That would be bracket first.
Left bracket.
Yes.
Okay.
13, comma,
13,
and
okay, 13, comma.
positive infinity and parentheses.
Okay. So looks like it'll be like that for interval notation. Everybody agree? X greater than or equal to 13, X greater than or equal. So here's a greater than or equal to 13, and it keeps going out. So the interval is going to be positive infinity, and we never reach positive infinity. Okay, how about graphical notation? Who can give me graphical notation? Here's my number line. Here's 0.
Well, there's going to be a bracket at 13.
All right, there's 13.
And then there's going to be a bracket there or a closed circle.
Okay, so here's a closed circle, and you want the bracket like this?
No, the other way around.
Oh, the other way. Okay, so you want the bracket that way. Okay, which is the same as the closed circle. Okay, good. Then what?
And then it would just be to infinity. It would be like a arrow at the end of the line.
Just an arrow going out like that. Okay, so we could say it's this thing here. Or we could put that there as well if we wanted to, couldn't we? All right, so we're saying graphically it would look like this, where we're going out to positive infinity. Okay. Who can give me set builder notation then? What's that going to look like?
Well, it will be x such 13.
X such that 13
l- X greater or equal 13. So x in the middle.
x greater than or equal to 13. Okay.
13, and less than positive infinity.
Okay. So if we do set builder, we could say all x is such that x is greater than or equal to 13 and x is less than or equal to positive infinity. Okay. Questions?
What was the original problem? I think I miswrote it down. So I was just
Oh, okay. So let's write down what we think the original problem was. I think it was x minus 4 over 2 greater than or equal x minus 2 over 3 plus 5 over 6.
great. Thank you.
Yeah. Other questions? How we doing?
So on the test, would we box all like the inequality x is greater than or equal to 13 as well as the three notations, or only the three?
Well, it depends on what the problem says. Here's the solution. If it asks to show all three notations, then you would say, well, I have one answer here that's interval notation. I have one answer here that's graphical notation, and I'm not asking you to put a box around this. You can if you want. And then set builder notation is between these braces. So 1, 2, 3 different notations.
Okay, thank you.
Yeah.
Wait, so on like the interval notation part, it's only like two things you use, right? That one bracket and then that one parentheses.
Yes.
Those are only two you use.
Yes. Yeah, an interval notation, we're going to look
There
at.
would be a case where like there's two of the same one, or it'll all just be the one and the other. Does that make sense?
Well, here's the lower value and here's the upper value, and they're separated with a comma. And this just says, do I include it or not include it? These brackets and braces and so forth. This just, am I including it? So in an interval notation, I use just brackets and parentheses. I don't use the braces there. The braces are
So
down here.
so all we have to know is just those two, right? Bracket
Yes.
and parentheses. Okay.
In interval notation, yes.
Got it.
For interval, we do that. For set builder, we use this guy.
Got it. Got it.
So we would come down to here like that. Okay, other questions? All right, let's see. We're out of paper there. Let's get another one. Now this next problem is going to look a little different. If I say 1 less than or equal to 2x plus 3, and that's less than 11. And again, all three notations. We want to solve and then put it in three notations: interval, graphical, and set builder. Okay, so this one looks a little different in that we have a value on the left and a value on the right. So we're going to separate this, and we're going to take this one and say we're going to solve for 1 less than or equal to 2x plus 3, and we're going to go down and solve that. And then on the right side, we're going to solve 2x plus 3 is less than 11. So we're going to do two paths here. So can we solve this left path? What's the next thing I'm going to want to do here to solve for x?
-3.
From each side, so 1 minus 3, that gives me a -2, less than or equal to 2x. And I divide through by 2. And I get x greater than or equal to,
Can you slide over your paper?
What's x greater than?
-1.
-1. Okay. So this left side, x is greater than -1. How about the right side?
Subtract 3
X
from
less
11.
than 4.
Subtract. Somebody said subtract what?
3 from 11.
So we're moving this to the other side by subtracting it from each side. 2x less than 11 minus 3 is 8.
And you get x is less than 4.
X less than 4. So we have two solutions. So we want to put the first in interval notation.
Wait, I have a question.
Yep, go right ahead.
So I'm used to like when you divide an inequality, don't you have to like flip the sign or something?
Did we have to flip the sign? Why did we have to flip the sign?
I don't know. The way I learned it is whenever you divide an inequality, you have to flip the sign the other way.
That is incorrect.
I think it's only if you're dividing or multiplying by negatives.
Yes, if you
Oh,
if you
okay,
multiply
yeah.
by a -1 or divide by a -1, then you flip the sign. I try and avoid that. But you can do it any way you would like. But once you start flipping signs around, you're liable to get yourself confused. So I prefer to just move the variables, but you are welcome to do it any way you'd like. So again, we got x greater than or equal to -1 and x less than 4. And we want to put that in interval notation. So what's that going to look like?
Is it going to be bracket -1 is
Bracket like this, -1. Okay.
is what's this? Is less than or equal to x?
Less than or equal to x like that.
Yes. And x is less than 4.
Less than 4. And then what? Is that it?
Oops, I forgot this is interval notation, so it's commas. My bad.
So what do we want?
It's going to be, I should have thought this through a little bit more. I think it's going to be -1, comma 4.
-1. Is that a question or is that a statement?
It's a statement, but it's an unsure statement.
-1, comma 4. And is that it?
And then like a parentheses, I think.
Parenthesis, you think. All right. Now there's a parenthesis.
The other way around.
You want it this way around.
Yes, please.
Okay. Anybody agree, disagree?
I agree.
Okay, we have one agreement.
It's the same answer.
Okay, so I'll put a box around that and say that works. We don't have any disagreements. How about in graphical notation? If we graph it, what is that going to look like? Here's my 0.
It's going to be a solid dot or a left bracket on -1.
So here's -1. So it could be this, could be that. Okay.
Over to 4, where there will be a parenthesis or an open circle.
Okay, so it might be this or an open paren like that.
And then a line to connect them.
All right, so we might have this, this, and that. Okay, how about a new volunteer for set builder notation? What is that going to look like?
X.
Oh, you know, that person forgot where that was.
X is such that -1 is less than or equal to x, and x is less than 4.
4, okay. Everybody agree?
Yes.
Okay, anybody disagree? Anybody get anything different? Okay, good. We're making good progress. Good work. How about we use absolute value? Now, if I give you something that looks like absolute value of not C, not constant, let's say absolute value of some unknown value equals C, where these mean the absolute value function, ABS. So absolute value of U equals C. That's what you're given. Then I can say, well, this U could be a positive U or it could be a negative U, couldn't it? And it would still equal C.
Yes.
Am I correct? Okay. So now if I multiply this second one by -1, I'll get U equals negative C. Okay. So now I'm saying U can be a positive C or U could be a negative C. Another way of saying positive or negative U could equal C. Okay. Just want to make sure we understand that before we actually work a problem. We're going to
Wait, did you explain the last one again?
Yes. That we knew that positive U and negative U could equal C, right? We could have a plus or a minus in here, but because we're just looking at the magnitude, we're going to say, well, whether it's a positive U or a negative U, it could still equal C. So these are equations that we know are true, correct?
Yes.
Okay. Now I can move this U to the other side and the C to the other side, can't I? And then I would get U equals negative C. So we're saying U can equal C or U could equal negative C. Just moved it around.
So how did you get U equals negative C?
Because I had from here, I had a negative U inside the absolute value. So there's negative U equals C. And I can multiply through by -1. It's just an equal sign here. So if I multiply through by -1, I get positive U is negative C. Or I could say, well, I want to move U to the right-hand side, add U to each side. That puts it over here. And subtract C from each side, and that puts C over here. So then we get U equals negative C. Either way, we're going to get U equals negative C.
Okay.
So now we have U can be positive C or U can be negative C. I'm just trying to make sure you understand how this works because I'm now going to use this approach on an actual problem. So let's say the actual problem looks like x minus 2 less than 5. And this is my U now, isn't it? This is the value inside the paren. And so I can say, well, x minus 2 is less than 5. But I can also say the negative of this. All right, so the negative of that is what?
Negative x plus 2.
Plus 2 is less than 5. Those are both true statements based on what I showed up here. So now I solve both paths. So when I solve this path on the left here, what do I get? What steps do I go through, I guess is what I should say. Here's my less than sign. I want to move this x over to the other side. How do I get it over there to get a positive x? I add x to each side, don't I? So now I've moved x to the right side, and it's a positive x. I've got the plus 2 here, and I want to get this 5 to the other side. How do I do that? I subtract it from each side. So this becomes negative 5 plus 2 less than x. I didn't do any multiplying by negative value. I didn't flip any signs. I just moved the values around this guy here. I didn't change that at all. There it is, There it is. So now I have x greater than -5 and +2. And what does that get me?
-3.
-3. So there's one solution, x greater than -3. Now let's work down this side. I'm going to solve this for x. It's a little easier, isn't it? Add 2 to each side. X less than, those cancel, 7. So the solutions are x is greater than -3 and x is less than 7. And now I want to put it in all three formats: interval, graphing, set builder. So in graphical notation, I'm going from -3 to 7. And then I have to decide, well, what kind of a symbol do I put over here? Do I include that -3?
No.
No, I don't. So I put a left paren here. Do I include the 7?
No.
Okay. So in interval notation, it looks like this. Okay. How about graphical notation? There's my line. There's my 0. And in graphical form, what is this thing going to look like?
So left parenthesis at -3.
1, 2, -3. There's that.
And then a right parenthesis at 7.
So there's a 7. And I put a right paren there.
Yeah. And you can draw your line between them. And if you wanted to do the other notation, you could do open circles at -3 and 7 and draw a
Okay.
line between them.
All right. So there we are, there and there and there. All right. New volunteer for set builder. There's the right or left bracket. And not bracket, but brace. So there's a left brace and a right brace. What is that going to look like?
X such that -3 is less than x and x is less than 7.
Patrick, have you already given me some answers?
I have. I'm just trying to hurry up the process because class is over.
Class is not over until 5:10.
Close
So
to over. Excuse me.
So we're going to let other people talk now, Patrick, if you don't mind. Go ahead, somebody. Okay, Bogdan, go right ahead.
I think you missed a line after the first bracket.
Up here or here? Where are we looking?
At like 3, before you usually put a line after that bracket. Yeah.
Well, you tell me what to put in here. I'm just going to put in these two.
Okay. I put in -3 is
So what's
smaller than
what's the first term I put here?
-3.
Is that the first term I put there? First term I put is x, isn't it? The variable. All
Okay.
x's such that, and I'll put the x out here, and then I'll put my greater than, less than, and so forth, just to make it easier. So here's set builder. Here's x. Now what do I put inside here?
-3 is smaller than x.
So that's less than?
Yeah, and then
Is it less than or equal or just less than?
just less than.
Okay. And then on the other
And
side?
then 7 is more than x.
So how do I stipulate that here? What do I put here?
So more than 7 after x.
More than 7 like that?
So it's other way.
Other way, x less than 7.
Yeah, sorry.
So we want x such that x is greater than -3 and x is less than 7. Okay, everybody understand that? Any questions on that at all? Now, keep in mind, I'm not taking attendance here, guys. If you're getting bored with what we're doing and you want to sign off, you can do that at any time. Okay, So I'm just going to kind of keep going through some additional problems and just see how we do. So let's say I give you, let's take a new problem here on the back side of this paper. Let's say I give you -3 absolute value. Let's say it's 5x minus 2. And we add 20 to that. And we say, that's greater than or equal to -19. Now we want to solve. Okay, and we may want to put that in all three forms: interval, graphical, set builder. And I have a 0 here somewhere. Okay, are we able to solve this? Any questions on what we do to solve that? What do we want to do? If we want to solve for x, we're going to somehow have to isolate this, aren't we? So if we want to isolate this absolute value of 5x minus 2, what are we going to do to get that by itself on the left-hand side of an equation? Is there any way we can do that? Or can we get it? If we want to isolate this, let's see, I could move this over, couldn't I? So if I said -3, 5x minus 2 greater than -19, bring the 20 over, it becomes a -20, doesn't it? So now what do I have on my right-hand side here?
A -39.
-39. Okay, good. Now, if I want to divide by this -3 to get rid of that, I can say absolute value 5x minus 2 is greater than or equal to -39 over 3, which is what?
It's 13.
Positive 13, isn't it?
It's positive 13.
Yes, okay. Now we're at the situation where we need to remember that absolute value equals C, so plus U equals C, minus U equals C, or U can equal -C. Remember we did that earlier? We went through that
Wait,
reason.
would you need to flip the sign or not?
We don't need to flip. We haven't done anything to flip signs. No, we have not. So what I do have to say, though, is if this is U, then U can be equal to C or -C. So that says that, well, if I had a -C over here, let's see, do I have that right? I have -13 over here, and I have positive 13 here, and I did something funny. You're right. I did something funny with my signs here. Let me go back and look at the original problem here. What is this problem supposed to look like? Supposed to be greater than equal to 19. That's good. That's good. So that's greater than or equal to, we didn't change anything there. We just brought that over 39. That's good.
Are you saying you want 5x minus 2 is greater than or equal 13, and also 5x minus 2 is greater than or equal to -13?
No, it's going to be greater than -13. It's going to be greater than this thing.
I think we divided by -3, so should we flip the sign then?
Yeah, I agree.
A negative divided by a negative is a positive. But
That's,
not,
let me think. Yes. Let me take a look. Yes. Good point. If we take this negative and divide, we do have to flip this sign. I missed that. You're exactly right. So once I do this, this sign changes to less than. Yeah, if we multiply or divide by a negative, we will flip the sign. I try and avoid that as much as I can, but I couldn't avoid it here because I was dividing. So I did have to flip the sign. So this goes to here. So now I have that 5x minus 2 is less than positive 13, and 5x minus 2 is greater than -13. So here's the equation that I want to solve. And that ends up as negative 13 less than equal to 5x minus 2. And on this side, 5x minus 2 less than 13. Now it's 5:10. It's over. Class is over. And the only thing we have to do is just solve these equations. And that's pretty straightforward, isn't it? 5x and bring the 2 over here. 5x, bring the 2 over here.
I'm not understanding the negative 13 that you added to the other side. Could you explain that again?
Yes,
please?
yes. Well, as we did with these things here, this value here for you, we're making that greater than a negative 13. It's either less than a positive 13. If I have the value here and I have positive 13, it's going to be less than or equal to that, but it's going to be greater than or equal to the negative.
So why are we switching the sign? I don't understand that.
Oh, because we divided by a negative number.
So you wouldn't be switching the other sign as well for the positive 13 that you're getting?
Well, when I
Okay,
did
I see where my mistake was.
when I did the divide, I got this value. And then from here, I said, well, if I want this to be on the other side of 13, it's going to be greater than a negative 13, because we're either going to have a positive or a negative C. Here's the value here. So it's either positive or negative. And here's our U value here.
So if you were to rewrite, I see where my mistake was, I think.
So now we just have to solve these guys. I think the whole concept that we want to make sure we get is that we put everything, we want to isolate this absolute value 5x minus 2. So we moved everything over. And then when we divided by the negative 3, we had to reverse the sign. That was the only. Here and here. And now we just have to solve each side. And when we do that, let's see, do I have an actual solution here? And over here, less than 3. So I go from negative 11 over 5. 11 over 5 is negative, here's 0, negative 1, negative 2. 11 over 5 is a little less than 2, isn't it? So it's going to be somewhere in here. And I'll call that 11 over 5 in the negative.
It should be just over negative 2. It's
Yeah.
negative 11 5/5.
Oh, yes, yes. Good catch. So it's going to be here. So if here's negative 1, negative 2, 11 over 5 is here. And we are including that. So we can put a solid line of that. And the right-hand side, we'll have let's see, we have a 3 because we've got 15 divided by 5 is 3. So 2 goes over, makes 13 plus 2 is 15 divided by 5 is 3. So we have a 5, 1, 2, 3 here. And we're less than or equal to, so we're going to include that. So we're saying we've got then the situation that x is greater than this left value, negative 11 over 5, and less than the 3.
Just for clarity, Professor, it might be good to put the negative symbol on the left of your page where you have 11/5 is less than or equal to x.
Right
Just,
here?
And to the left of that on your page. You see where you've got it written to the left of where you're circling?
Oh, over here.
Yeah,
Yes.
just for clarity.
Yeah,
I didn't know if people were.
Yeah, okay.
So I had a question.
Yeah, go right ahead.
So how did
Now,
you get,
now class is over. Whoever wants to leave, feel free to leave. Now I'll just take questions at this point. Go right ahead.
so how did you get the negative 13 is less than or equal to 5?
Recording stopped.
That came from up here.
So my confusion is there also, because I would have thought it would have been 5x minus 2 is less than or equal to 13, and also 5x minus 2 is less than or equal to negative 13.
Yes, me too.
Well, let's take a look here. If we say
It just, I'm
Those
not.
both say the same thing, though.
Are they? I'm just
If
not.
the way that you just said it, that means the same. If 5x minus 2 is less than 13, but also less than negative 13, and that's a given. So there would be no point in saying it's less than 13 at that point, right? Because you know it's less than negative 13, which is, well, further down the number line.
Okay, I see what you're saying.
Just so you know where you can say, okay, I know that
For
isn't
sure,
right.
that clarifies the where it's on the other side. So thank you, Chris. I appreciate that.
Right, of course. I think the professor could still, go into detail why you're swapping the signs, because that is a weird operation to do. But yeah.
well, this sign, this less than or equal, greater than or equal, we swap that because of this divide by negative value.
Right.
So my question was that I thought it would be negative 13 is greater than or equal to 5x minus 2.
Negative 13. So you want to put the 5x minus 2 out in this area.
I mean, in the equation we had negative 13 is less than or equal to 5x minus 2.
Yes, that's what it should be.
But wouldn't it be negative 13 is greater than or equal?
No, because we're moving it to the other side. We have some value here, 5x minus 2, and it's less than this value, but greater than the negative of that value.
Do you mind showing the original equation?
Yeah, up here. Negative 5 times the quantity 5x minus 2, and that's absolute value. Plus 20 greater than negative 19. That's the original equation.
Professor, if you don't mind, I'm going to interject really quick.
Yeah, go right ahead.
I don't want to, I understand this, so I don't personally want to stick around for more explanation of this, but Patrick, please hit me up on Discord. I messaged you on there regarding these problems. Okay.
Thank you, Chris. Appreciate it. We'll talk to you then.
Of course. Bye. Thank you, Professor, for
Sure.
your time.
All right.
So Mike, because the rule is that u is equal to negative c, so u here is 5x minus 2, and 5x minus and c is 13. So that means according to that rule, it would be 5x minus 2 is less than or equal to negative 13, which is the same as negative 13 is greater than or equal to 5x minus 2. But then how are we getting the negative 13 is less than or equal to 5x minus 2?
This, you're talking about this side here? You're talking about this side here, right?
Yeah, because it should be the opposite sign, I think, because after we divide it by negative.
If that were true, let's take a look at what we'd have. Here's 0. 5x minus 2 is less than 13. So 13 is out here. So it's less than that. So that means it's going to be somewhere in this direction, right? Just out here. And then if we say 5x minus 2, and you want to make that less than negative 13. So here's negative 13, and less than says it's out here. So the first half says it's less than positive 13, and the second half says your way says it's less than negative 13. Does that make sense? It's less than this and less than this. Why do we say this? This is less than this. So we don't need to say this anymore. If that were true, then we don't have to say that. We can just say, well, it's less than negative 13.
Okay, so I think I might have gotten the equation written down wrong somewhere. So do you mind if I copy down the equation and then solve it on my own, and then I will email you if I have any questions?
Sure.
I have a question.
Yes, please.
It was on P5.
Yes. Oh, we're going to go to a different.
Well, number 101. It was basically